Okay students, now the second part of this no load and rotor block test on squirrel cage induction motor we will see, that is no load test on 3-phase squirrel cage induction motor. So we are going to consider 3-phase squirrel cage induction motor as shown here, and of course the same nameplate details I am showing now. Now before going to give the connections, first let us see the circuit connections of no load test. We have shown here the circuit diagram. Please observe, this is no load test circuit diagram. Again same, nothing difference here, only thing is the brake drum is not connected and the range of ammeter are consider again this ammeter range. Already we have seen the nameplate details of ammeter, it is shown as maximum 7 amperes. So obviously you can go for 10 amps range, same MI instrument, and of course here we are operating the machine at its rated voltage. That is why the range of this voltmeter should be is changed. So we are going to take it as 600 volts. The reason for this 600 volts is what? From the nameplate details we have seen that 415 volts, that is the rated or 400 volts. 415 volts is the nameplate detail. Therefore the nearest range of this voltmeter should be 600. Hence we are, and that too we are applying rated voltage directly here. That is why we will take the range of this voltmeter as 0 to 600 volts. And of course again same double element wattmeter where MV is shorted, C is connected as shown here, and of course this should be 10 amps, 600 volts. Actually you can go for, if you are going for two individual, that is single phase wattmeters, then LPF wattmeter is to be preferred. But we are using double element here itself. Straight away we can employ UPF wattmeter instead of LPF here. So once if you are thorough with the nameplate details and the connections are shown here, same thing, that means the connections are shown as are connected as per the circuit diagram, and you can observe the same is taken here. Again 3-phase variable where its input should be 0. Input in this auto transformer is given from R by B, and output connections are taken same as that of rotor block test. You can observe first terminal of output is taken to one as to ammeter and the other one to voltmeter, and voltmeter other end is connected to Y here. Ammeter other end is connected to M of wattmeter, first terminal. MV is shorted and L is connected to junction of both A1 and C2. And similarly from Y it is connected to common terminal, and from common you can observe junction to C1 B2 where C1 B2 is junction. The other terminal, that is third terminal B, is connected to M of second wattmeter here, that is second element. MV is shorted, and please observe the V is taken 500 volts. Earlier in the case of rotor block test we took 250 volts, whereas here we are going to take 500 because we are going to apply rated voltage. That is the reason 500 volts is considered here. Similar first second element here, and even for first element also 500 volts here. And L of this is taken to again same junction of B1 and A2. Once if we finish this connections as per the diagram, now we go for conducting no load test on this. Before going to conduct this experiment, ensure that load on this should be 0. Ensure that load on this should be 0. Load on this machine is to be 0. See here it is showing 0 reading and it should be freely rotating. That finishes no load condition. So that means whenever we run the machine it should be run very easily. After ensuring no load on the machine at 0 reading, then give 3-phase supply to the auto transformer input, and now we are going to apply rated voltage on the induction motor. Rated voltage. You can observe I am going to vary here and see the voltage rating is increasing slowly, and you can observe induction motor running also. You can observe induction motor running. So straight away I am applying 400 volts. Straight away I am applying 400 volts. You can see here 400. Now we can observe no load current rating as shown here. It is something showing as what? Some 3.7 amperes, and this is the wattmeter rating. You can observe wattmeter rating showing in between 0 to 1, not exactly at center, but above center, 100 to 200 in between. So something around we can take like 120 watts like that. So now we have to note down the readings for no load test. No load test on 3-phase squirrel cage induction motor. So voltage rating 400 volts, current rating as I said it is 3.7 amperes as no load current. This will be ISC or blocked rotor current. Some people will also call it as blocked rotor current, blocked rotor voltage and blocked rotor watts. So here no load voltage, no load power, and no load power is 120. And you please observe the reading is 120, but what about multiplying factor? We have to calculate that multiplying factor. Again same procedure. Voltage 500 volts, current 10 amperes. Of course, unity power factor we have considered. 500 into 10 into 1, it is 5000. And what is the maximum deflection, full scale deflection? 2500. So 5000 divided by 2500, it will be 2. And that is for one element. Since it's a double element, the multiplying factor will be again multiplied by 2. 2 into 2, that is 4. You can also check it here. 10 amps, 500 volts, the multiplying factor is, it is shown as 4. Actually it is 4, it is shown. Therefore, the reading that is obtained from the wattmeter is to be multiplied with 4. So you can write approximately 480 watts. So actually even that should be, sorry, you can see it here. You can take 0 to, whether you can write 100. So please be careful while writing this. It is 100, not 420. So you will be getting approximately 400 watts. This is about no load test on 3-phase squirrel cage induction motor, and the readings are as shown here. So once if you finish this taking down the reading, slowly reduce the voltage again to 0 and then switch off supply, that is open TPS switch. That finishes the no load test on 3-phase squirrel cage induction motor. Thank you very much. Later on we will see how to draw the circuit diagram from no load test and rotor block test. That procedure and the complete step by step will be shown in the next video. Thank you very much.